Hey guys, welcome to another math video. For this video, I'll be talking about parabolas, not parabolas. It's not a disease. It's pronounced parabolas. Okay, so here's the different things we'll be doing. I'll go over all of these things. I know they sound kind of weird right now, but you'll see what they are. Okay, so parabolas are basically graphs of curves. They can either be a function or a relation depending on which way they open. Okay, so if it's a vertical parabola, you'll see them in this form where x has the exponent. If they're horizontal, meaning they open sideways, left or right, you'll see y with the exponent. Okay, so let's talk about the vertical parabolas first. So this one opens up and down. This is the parent equation. Okay, so vertical parabolas are functions. Okay, so a vertex form looks like this, where a is a real number between 0 and 1, or a real number greater than 1. H and K are the coordinates of the vertex. Okay. And also, you can use them in translations too, where H moves the graph left and right, K moves it up and down, A makes it shrink or stretch depending on what the value is, like I mentioned earlier. Now this one here is the application in pre-calculus. Okay, so again, vertex is H and K, so that doesn't change. What's new is this thing called the focus, where we have this P here, and P is a multiple of 4. Okay, so the focus will have the coordinates, it's a point, H, K plus P. So the focus will be inside of the parabola. We also got this other thing called the directrix. So the directrix is, think of it as like a horizontal asymptote for vertical parabolas, where it's in the form y equals k minus p, so it's in the form of an equation. Okay, and this will be outside of the parabola. So let's see here, and the axis of symmetry we have here is x equals h, where h is the x coordinate of the vertex. Yep. So this is also always in the form of an equation, x equals. Yep. Okay, so here are our vertical parabolas. You can see they open up or down. That's the basic gist of it. Okay, so now let's take a look at this example here. So we're going to identify the vertex, axis of symmetry, focus, and directrix. So let's start with the easy one first, the vertex. Okay, so remember the vertex was HK. So H was the x coordinate of the vertex, K was the y coordinate of the vertex, and you can see here they hang out with their corresponding variables. Okay, so that means this is H and this is K. So there's our vertex. Okay, so now next we'll find the axis of symmetry. Since we have the vertex, that's the easy part. That next easy part, because the axis of symmetry. Here we have the x with the exponent. So this is going to be a vertical parabola. So the x-axis of symmetry is going to be the x coordinate. X equals h in this case. So axis of symmetry would be x equals 3. Okay, so next thing we'll find is the focus, or we could find the directrix. Either way, we need to find P, because both the focus and the directrix uses P. So the next step is to find P. So remember, it was this value here equals to will be equal to 4p. Okay, because this value here is p is a multiple of 4. So we'll just solve for p. So basically what I'm saying is we're taking this value, making it equal to 4p, and solving for p. So this p here will be what we need to find the focus and the directrix. So for the focus, remember the focus was a point that's inside of the parabola. And since this is a vertical parabola, we're going to add p to k. Okay, so 2 plus a negative 2, like 2 minus 2. So focus is 3, 0. And that's inside of the parabola, which means this parabola opens down. Okay, next we'll find the directrix. Okay, so remember the directrix was in the form y equals k minus p. So k minus p, so 2 minus a negative 2, which simplifies to 2 plus 2, which is 4, and it's always in the form, in this case, because it's a vertical parabola, y equals k minus p, y equals 4 in this case. Okay, so let's take a look at some horizontal parabolas. So remember, horizontal parabolas open left and right, and you see them in this form where y has the exponent. Okay, so vertex form looks similar. The only difference is well, remember k is the y-coordinate of the vertex, so it stays with its corresponding variable. Okay, so all the different parts are still the same. Okay, so now here in this case, we have it switched in this form, where the 4p is with x minus h, and the y minus k has the square. So all the different parts are still the same. So the vertex is still h and k. The focus this time, because it's a horizontal parabola, h gets added to the p, or the p gets added to the h, because the focus is still inside of the parabola. So it's going to move horizontally rather than vertically. Yeah? And the directrix this time is going to be x equals h minus p. So this time it's going to be a vertical line rather than a horizontal line. Okay? And their axis of symmetry will be y equals k. Okay, so let's take a look at an example here. I know this is kind of confusing. So we'll take a look at the pictures before the example. So these are horizontal parabolas, and horizontal parabolas are relations because they fail the vertical line test. Okay, so for this example, we got the equation y minus 1 squared equals 8 times x plus 4. So we're going to find the vertex, axis of symmetry, focus, and directrix. Basically everything like in the other example. So again, we'll start with the vertex because that will be the easiest thing to find in this form. So the vertex, hk, so our vertex is negative 4, 1. Now we can find the axis of symmetry. So since y has the square, we know this is a horizontal parabola opening left or right. So that means our axis of symmetry will be y equals k. So y equals 1. Now we need to find our focus and directrix, but before we can find those, we need to find p. So we'll take this value here and make it equal to 4p. Solve for p. Okay, so now our focus, since this is a horizontal parabola, our focus is going to be h plus p, comma k. So we're going to add this value to h. Okay, so there's our focus. Now our directrix is in the form x equals h minus k. So we're going to take this value and subtract it from h. Okay, and remember, it's always in the form x equals h minus p. Okay, so make sure you always write it in the form of an equation. It's the same for the axis of symmetry. Okay, it doesn't matter which way it opens, those two things are always in the form of an equation. Okay? Okay, so basically all these things we did. You're probably wondering why we did all those different things. Well, the basic application for parabolas, especially with the focus and directrix, is parabolic dishes, or as people commonly know them as satellite dishes. So if you have satellite at home, the satellite companies hire engineers to use these formulas to figure out where to place their focus and the best alignment for your dishes. But anyway, that's a tangent. That's more of a physics thing. Well, if you need to take a look at the examples again, feel free to rewind. Any questions, leave them down in the comments. I'll get back to you as soon as I can. Otherwise, thanks for watching. Thanks for tuning in. Subscribe if you haven't done so already, and I will catch you next time.